In this video we are going to see how to find the longest common subsequence between two strings. So first we need to understand what is longest common subsequence. So there are three terms: longest, common, and subsequence. So this common means it should be common to both the strings, and longest means it should be the longest possible value whatever we are calculating. And subsequence of a string means if we have a string A, B, C, D, E, then we randomly, if we pick randomly some of these characters like BC, then BC is a subsequence of A, B, C, D, E. If we pick B, D, and E, this is also a subsequence. So we see that their relative ordering is same. Like B came before D, and in the original string also B comes before D. Similarly, D comes before E, and so their relative ordering is maintained. So this is the definition of substring. So we are picking some partial or even complete of this substring of this original string, but their relative ordering is preserved. So let's find out what is the longest common subsequence of these two strings. So here A is present in both, then G, then T, then B. So this is the longest subsequence, longest common subsequence of these two strings of length 4. Now how to solve this? So there are two cases. So we have G A G A T B and X A T G T Y B C. So first we will compare their last characters. So these are not equal. So these are not equal. That means either either C can be part of the substring longest common subsequence, or B can be part of the subsequence. So if C is part of the subsequence, then it has to match with this part of the string. It cannot match with B because we know it's not equal. So if C is part of the subsequence, final subsequence, then it has to match to sub character from this part of the string. So if its length is M and its length is N, then and the string starts from 0 to M minus 1, then we can solve the same problem. So this is P, this is Q. So either C is part of the subsequence or not. If C is part of the subsequence, then we will solve from 0 to M minus 2, because we know M minus 1th character does not equal to C. Or if C is not part of the subsequence, we can simply ignore it. The second case is if B is part of the subsequence or not, then it has to match to this part of the string 0 to N minus 2. So in this case Q will remain complete because we are comparing the complete Q with this part of P. So Q is complete 0 to M minus 1. In the second case, if B is part of the subsequence, then we will take P 0 to M minus 1 and Q 0 to N minus 2. So these are the only two possibilities when the last character is unequal, because both cannot be part of the subsequence. It's not that B is also part of the subsequence and C is also part of the subsequence, because these are the last characters. So in the subsequence also these has to come last, but only one can come last. So either B matches with this part of the string or C matches with this part of the P. So there are only two cases. So if P of m minus 1 is not equal to Q of n minus 1, then we have to take max of this whatever, if this function is L, max of L P 0 to m minus 2 Q 0 to n minus 1 and L of so this is the case where the last character are not same. Other case is if P of m minus 1 is equal to Q of n minus 1. So if that is the case, we have some string, let's say A, B, C, D, and B, A, D, and here the last characters are same. So straight away we know that we will lose nothing by adding this to our subsequence, because if our subsequence is some string and D is the last character, so we will gain nothing by ignoring them. We can always add D because D is in the end. So in that case we straight away pick the last element. So we have one character in the subsequence and we are left with this part of P and this part of Q. So we subtract 1 from both P and Q. So it will be 1 plus L of P0 to m minus 2 Q0 to n minus 2. So these are the two cases. So let's write down this at one place. So L of P0 to m minus 1 Q0 to n minus 1 is equal to 1 plus if last character match or max of if last character do not match. So these are the only two cases. So now we can draw the recursion tree using this approach, simple recursive approach. So we want to find for mn length string So we will need these two values. If they are not equal, if they are equal, we will need m minus 1, n minus 1. So this again m minus 1, n minus 1 and m minus 2, n. And this again m minus 1, n minus 1 and m, n minus 2 and so on. So you see that this is just the second level of this recursion tree, but you can see the problems are sub problems are matching. Like we will need this, and here also we are solving this. So whatever tree is below this, if we solve all these values once, we should not use those values again, because that will be resolving the problem. And similarly from here, one tree will be m minus 1, n minus 2, and one will be m, n minus 2. And from here it will be m minus 2, n minus 1 and m minus 3, n. So many of these will overlap. So this recursive solution is not ideal, and we should use the dynamic programming based solution. So for that, let's copy the original text in our example, and then we will create one table for storing the values. So we have G, A, G, A, T, B. So let's illustrate this further. So here the value of, if any cell is at index m minus 1, or rather take it mn, then if the characters are same, then we will move to m minus 1, n minus 1, this cell, that is diagonally up. And if they are not equal, we will take maximum of either this or this. Like from the definition of this, if they are equal, then we move from n minus 1, m minus 1 to m minus 2, n minus 2. So this cell is mn, then we will move diagonally up. If m is increasing in this direction and n is increasing in this direction. So to summarize, if they are equal, we will take the value of this cell and add 1 to it. If they are not equal, we will take the maximum of either this or this. So we will need just these three cells to calculate the value of this cell. So now let's fill this table and we will solve the problem in the bottom up manner. So this side is Q, this side is P. So if we want this value of this cell, it means this part of Q, that is from beginning to this part. So we are interested in this part. If we are solving for this cell, that means we are interested in this part, that is GA and XA. So this will be the meaning of cell. So here what this cell means, there is no string here, that is empty P. So if P is empty, then whatever is the value of Q, the longest subsequence will be empty only. So put zeros here, and similarly if q is empty, then also everything will be 0. Now let's solve for this cell. This cell means we are interested in this part. So x and g are not equal, so we will take the maximum of these. So these are both 0, so maximum of these is 0. Now we come here. It means we take GA and X. So X and A are not equal. So we will take maximum of this and this. Both are 0. So again 0. Then we come here. Max of these two are again 0. Similarly here, here and here. Now we compare A with G. Again they are not equal. So we will take max of this and this. So it's 0. A and A, this is equal. So we will add 1 plus whatever is the value of this cell. So this is 0. So 0 plus 1 is 1. Now A and G are not equal. So we will take max of this and this. So it is 1. Now A and A are equal. So we will take 1 plus the value of this cell diagonal up. So 0 plus 1 is 1. Now A and T are not equal. So we will take max of this 1 and this 0, which is 1. Again A and B are not equal, so max of these two is 1. Now we come to third row. So here G and T are not equal, so we will take max of these two, which is 0. Then A and T are not equal, so max of these two is 1. G and T are not equal, so max of these two is 1. A and T are again not equal, T and T are equal, so 1 plus this diagonal cell. So it will be 1 plus 1, 2. Now T and B are not equal, so max of these two, which is 2. Now here G and G are equal, so 1 plus this element, 1. Again 1. G and G are now equal, so 1 plus 1, 2. G and A not equal, so max of these two, 2. Max of these two, max of these two. Then T and G are not equal, so 1. AT not equal, 1. TG not equal, 2. 2. T and T are equal, so 1 plus this value, that is 3. Then T and B are not equal, so 3. Here 1. Y and A are not equal, so 1. G and Y are not equal, so 2. A and Y 2. T Y 3. Y B 3. Then B G 1. B A 1. B G 2. B A 2. B T 3. Here B and B are now equal, so 1 plus this value 3, so 4. Now CG 1, 1, 2, 2, 3. CB are not equal, so max of these two, 4. So this cell denotes take the complete Q and take the complete P. So the maximum length of the substring is 4. So which is what we had seen earlier, that the maximum length is 4. So how we will find, so this only gives us what is the length of subsequence. So first let's write the DP code for that, this approach. I will call it LCS DP, and again P, Q, M and N. So I will take one array L of size M plus 1, N plus 1. So this is the same array that we used here, and then start filling the table in the bottom up manner. I equal to 0 to M, and J equal to 0 to N if I is equal to 0 or J is equal to 0. So that corresponds to this row and this column of all zeros. Then we will put zeros there. If the last characters are equal, then what we will do, we will take the diagonally upper element and add 1 to it. And if they are not equal, this is the last case. Then its value will be max of so these are the two neighboring cells to the left and to the top, and this is the diagonally upper cell. So these are the two cases, and finally we will return L of Mn, that is this element here at the this corner element Mn. So this is the DP based solution. So with this I will end today's video because it's getting too long. In the next video we will see how to print the actual subsequence that